Why is the sky blue? The sky appears blue because of a scientific phenomenon called Rayleigh scattering. It is not because the ocean reflects its color, as many people think, but because of how sunlight interacts with Earth's atmosphere. Although sunlight looks white to us, it is actually a mixture of all the colors of the rainbow: red, orange, yellow, green, blue, and violet. This light travels in the form of energy waves with different lengths. Red and yellow colors have long wavelengths. Blue and violet colors have shorter and more energetic wavelengths. When sunlight reaches Earth, it enters the atmosphere and collides with gas molecules in the air, such as nitrogen and oxygen. The longer waves, like red and yellow, pass through the atmosphere relatively easily because they are not strongly affected by tiny particles. But the shorter waves, especially blue and violet, collide with these molecules and scatter in all directions. This is what we call Rayleigh scattering. It happens when the particles are much smaller than the wavelength of light. In our atmosphere, nitrogen and oxygen molecules are perfect for this interaction. When light hits them, they absorb the energy briefly, then re-emit it in different directions. There is an important physics rule. The intensity of scattering is inversely proportional to the fourth power of the wavelength. In simple words, the shorter the wavelength, the stronger the scattering becomes. Since blue light has a much shorter wavelength than red light, it scatters about 10 times more strongly. That is why we see blue light spread across the entire sky, while red light continues traveling in a nearly straight line. But here is a puzzling question. If violet has an even shorter wavelength than blue, why doesn't the sky look violet? The answer depends on 3 important reasons. First, the sun does not emit all colors equally. It produces more blue light than violet light. Second, the upper atmosphere, especially the ozone layer, absorbs a significant portion of violet light before it reaches us. Third, our eyes are not equally sensitive to all colors. The cones in our retina are more sensitive to blue light, while violet appears weaker to us. That is why we see the sky as blue instead of violet. Now, what happens at sunset? When the sun is high in the sky, light travels through a shorter distance in the atmosphere, so the sky appears light blue. But at sunset, sunlight travels a much longer path through the atmosphere. During this long journey, most of the blue light scatters away. What remains are the longer wavelengths, such as red and orange. That is why the sky turns red or orange at sunset. To understand this better, let's look at other worlds. On the moon, there's almost no atmosphere, so there is no scattering, and the sky appears completely black. On Mars, the atmosphere is thin and full of dust. During the day, the sky looks pinkish or brown, but at sunset, a blue glow appears around the sun. But the story does not end here. Air pollution and volcanic eruptions can also change the color of the sky. Larger particles cause a different type of scattering called scattering, which can make the sky look pale or gray. Massive volcanic eruptions can create deep red and even purple sunsets. In the end, the blue sky is not just a beautiful color. It is physics happening above us every single day. So here is the final question. What if Earth had no atmosphere at all? What would our world look like?